Thank you. Thank you very much for this super nice introduction. So I can skip my introduction slide. That's perfect. Yeah, I am looking forward to spending 45 minutes with you together on a topic which is very near to my heart. It's building web APIs in Rust with Axum. I have to admit, I'm a big fan of Rust. I have discovered Rust for me quite a few years ago. I started a Rust meetup, Rust Linz meetup. Maybe you've seen it already on YouTube or something like this, where we meet roughly monthly and talk about this thing. And today we are going to take a look at how to build web APIs with the framework Axum. You will see a lot of code, but don't worry if you are new to Rust. You will fall in love with Rust today because this language is so beautiful. Before we take a look at the code, let me quickly answer one important question. And this question is, why? Why should anybody care? Why shouldn't you use, I don't know, your favorite language like TypeScript or C# or Java or Go or whatever to build web APIs? I mean, they are famous for being super productive in that area, aren't they? So why Rust? Well, the first argument is speed. That's absolutely no question. Rust is fast. If you compile Rust, then you get machine language code. You do not have some intermediate language code which has to be compiled just in time to machine language. It's compiled down to the metal. And also, Rust doesn't have a garbage collector. In contrast to JavaScript, to Go, to C#, to Java, there is no garbage collector. That means memory management is super, super fast. And the frameworks are also very fast. I know benchmarks are always such a thing, but nevertheless, I looked at one. Let's take a look at one of the benchmark tech and power benchmarks. Let's take a look at a web framework benchmark, which many of you know. And if you take a look here, then you will see that already on place 8, we see the Axum framework, which is Rust. You see the Actix framework approximately at the same level, which is also Rust framework. We will not take a look on Actix today. But you see, Rust is really, really fast, even if you take a look at industry-wide benchmarks. The next reason why many people take a look at Rust is safe. Rust is safe. In contrast to other languages, including managed languages like C#, Java, Go, and JavaScript, Rust guarantees memory safety, and that is super important. Imagine that you build a web API which should operate or help to operate your production line or something like this, then you need memory safety. You need to be sure that there are no race conditions in multi-threaded code and things like that, and that is exactly what Rust can give you. So we are safe and we are fast. The next thing that we are is we are low level. Rust is a system programming language and an application programming language. You can dive as deep as you want. If you want to stay on an application development level, you will be very productive when building applications. But if you need to go down to the metal, if you need to interact with C libraries, if you need to interact with hardware, if you need to embed some lines of assembler code, you can do all these things in Rust. Rust gives you a lot of possibility to dive as deep as you want. And finally, and that is my most important topic here, it is a beautiful and elegant language. And this is exactly what I would like to demonstrate to you in the upcoming 40 minutes. That's it. That's my introduction. I hope you are now curious and you want to see code. I announced the session to be code heavy, so you only saw a few slides and now we dive right into code. And don't worry, if you are new to Rust, you will be definitely able to follow. Let me quickly ask you for a show of hands. I see a video image from the room. Can I have a show of hands? Can you raise your hand if you are an experienced Rust developer? Okay, one. Can you raise your hand if you have done a little bit of Rust development? Okay, so we have a mixture. We have a mixture. Okay, that is good. Oops, I don't need that one. So let me go into my demo environment here. And here I have set up a very simple sample application in which we will add a bunch of code. I will not write a lot of code. I will use so-called snippets. So what I have prepared here is I have prepared a bunch of snippets because otherwise I wouldn't be able to tell you all the things that I want you to know about this Axum framework and Rust in 45 minutes. So I cannot type everything from scratch. This example is obviously available on my GitHub repository. If you want to have it, just send me a direct message. I can send you the link, and I will also share the slides with the conference organizers. So don't worry, you will get this code. You do not need to take notes. Let's start the app just as it is here, and we can do that by saying just run. And you will see that is using the so-called cargo watch statement. So in the background, this code up here will be continuously compiled, and we can always use it to experiment with it. Okay, so I can get rid of that one. If that just command is new to you, I highly recommend taking a look at just files and the just command runner. I really like it. I like to use it in conjunction with Rust applications. If you ask me, it's very handy. So let's get started. First, we want to add a little bit of code here in the main function. But before we do that, I will turn this main function into an async function. And that is a very important first thing. I want to add here a Tokyo main. That is the first thing that I want to emphasize here. Let me go to the browser again and take a look at tokyo.rs. If you are new to the Rust environment, you have to understand that Rust has no async runtime built in. That is different compared to Go or C# or Java or whatever you have. They have async runtimes built in. But Rust has a system is very composable. You can tailor it to your specific needs. And one async runtime, which is very, very, very popular, is Tokyo. Tokyo consists of a so-called technology stack, as you can see it here. There is the async runtime, as you can see here. There is a web server called Hyper. There is low-level I/O, which is called Mio. There are some additional crates like tracing and so on. You can take a look at tokyo.rs to learn more. And the important thing is that Axum, the framework that we take a look at, is built on top of the Tokyo stack. It comes from the Tokyo project. Therefore, it's very nicely integrated in all the different crates which come from the Tokyo ecosystem. Okay, so this is a very important takeaway. If you work with Axum, you work with tools from the Tokyo stack, and you can use lower level elements, building blocks, like for instance Tower, to build middlewares in Axum and so on. I will not go into the details here because I'm limited to 45 minutes. So we will really focus on the Axum part. The other parts are for your research or are a topic for another talk that I could give at another conference. So now we have an async main function. That is nice. And we can add the first hello world. I have to delete a bunch of lines here. And now we are good. Let's take a look at the basic setup of the web server. Let's get rid of that one so you can see everything clearly. What you see here is the hello world of Axum. It's really as simple as that. What you do is you set up a so-called router, as you can see it here. You define your routes. In this case, I'm just listening on the root route, just a slash, and then I specify a handler function. And in this case, I am specifying a closure, an embedded anonymous function. It's called a closure in Rust, and the syntax is like that. In many other languages, you often know syntaxes like that, where you write the code like that, lambda function, but in Rust, you write it with these double bars, and you can put some parameters in here, and in this case, it's just an async block, which returns hello world. Okay? Then we set up a server, bind it to an IP address, that's my 000, so my local host, then a port, which is 3000, and then we simply say serve await. Unwrap is just panic if something goes wrong. We are not going to dive into unwrap here. So that is the hello world of Rust, and it already works. I can show it to you. Let me show you the requests file. If I send the request here, I will get back, hopefully, here is hello world. This is what I wanted to show you. So you see, it's absolutely not difficult to get started. We need a router. Then we use the route function to specify the route pattern. And then we use the HTTP verb. Here we could use get and post and put and patch and delete and things like that. And then we simply specify a handler function. That's it. Bind it to a server and you're ready to go. Not difficult. Of course, in real world, you will not write your handlers like that. That's nice for hello world, but in real world, you really want to have your handler functions in separate functions. And this is exactly what I did here. So I created a separate function, which is called hello world, as you can see here. And this hello world returns a so-called static string, which is just a pointer to UTF-8 in memory. And we return again hello world. The point of this is that I show you how it's different from using a closure to using a dedicated function. Now, that is all we need to do. It's pretty simple to allow that one. We can easily say here, instead of this handler function, remove that one and say hello world without calling it. It's just a pointer to the function. And we immediately have exactly the same behavior. I can prove it to you. Just call this one and it works. As you can see, it's really as simple as that. Now let's dive a little bit deeper, because that is, well, kind of trivial. Let's add a little bit more interesting routes. And I will do that exactly here by adding the next one, because here I would like to show you how you can answer different HTTP verbs. As you can see here, we again have the route, the same route pattern. But this time, I'm not just using the get method here, I'm also using the post method here. I'm not doing anything with the data which is posted to this handler function. I'm just returning a slightly different message. So let's get rid of that one. And now we have a get handler and a post handler. Should work really nicely. If we go to HTTP, get still works, post still works. As you can see, we have a slightly different message. So handling different verbs is really not a difficult thing. If you have any questions, please raise your hand. I see the people who are in the room, and you can get a microphone or simply start talking. I think I can hear you even if you don't take the Microsoft in your hand. So you see, getting started is really simple. Now, next level. Let's dive a little bit deeper. Again, I will add a little bit of code. And here I need this one. Now, this is an interesting thing here, because here I show you how you can structure larger applications into modules. Because you can imagine, if you don't have just a single route here, but if you have dozens, maybe even hundreds of routes, it becomes inconvenient to put all the routes on a single spot. What you typically do is you structure your application into modules, maybe even crates, and then you want to add a whole bunch of subroutes by just calling a route building function. And that is exactly what you see here. Let me zoom in so you see it quite nicely. Here, I am building a function which is called ping pong, which sets up the route ping and returns simply pong. And the important thing is that we simply return a router. And then we have a second experiment, which is called King Kong. And here we have the route king, and it returns Kong, as you can see it here. But the important thing is that we can simply return a router here to modularize our larger application. Please use your imagination. In real world, these things here that you see here would be larger modules or crates where you publish dozens or even hundreds of routes, as I said before. So what we can now do is we can go up here and embed this thing into our routing world. And we do that by calling the merge function. We simply say, hey, please merge the ping pong. And we can also say nest if we want to have a subroute, for instance, /King Kong, and specify that it should read the different routes from King Kong, as you can see it here. So this is our function which returns a router. This is our function which returns a router. This simply merges our routes top level, and this nests our routes under a common subroute. So very simple way of modularizing the APIs. I can prove to you that this really works. We can call ping, it returns pong, and we can call king, and it returns Kong. As you can see it here, this is now a subroute. Okay, sounds good, looks good, works fine. Next step. Obviously, a handler function which doesn't receive any parameters like query string parameters or path parameters or some JSON which comes from the HTTP body is not very useful. So now we are going to take a look at a very, very important abstraction in Axum, and that is called the so-called extractors. Let me show you how that works. I will add the next snippet, which is that one. And this snippet demonstrates how extractors work. This is an extractor, path. It simply says, hey, extract something from the path. And as you can see here, I will copy this route statement up in a second. Here you see that inside of the route, you can use placeholders. And in this case, we tell the router of Axum that we want a placeholder called name to be mapped to the path extractor, which is also called name. And then I simply use the format macro to return hello and the name that I got. Let me show you how this looks. I will copy this one up here, the route. Here it is. And we will simply add it here after this route. I will add this route. And if I now go to my requests and if I say greet Rainer, it says hello Rainer. And if I say greet Max, I will get back hello Max. So it works perfectly fine. It does exactly what it's supposed to do. And what you have to keep in mind is this concept of extractors. Path is exactly such an extractor. You can read a lot of details in the Axum documentation, which is really good. You get a lot of examples from Axum. And of course, you can write your own extractors. If you want to extract your own data type from the query string, or if you want to extract it from some HTTP headers and things like that, you can write your own extractors. So this thing is really extensible to a high degree. Okay? Good, very nice. So this is the the path extractor. The next thing will be the query extractor. So if we use something like this, if we want to extract something from the query string. Of course, this also works in a type-safe manner. This is what Rust is famous for. And let me show you what I mean with that. Let's add the next extractor. Here you see the extractor. Now it's called the query extractor. But the question is, what query string parameters do we offer? And the answer is this one. So you build a Rust structure. In our case, it contains an optional string which will become the salutation, an optional string which will become the name. Both are optional. And this is what we extract from the query string. And then we simply extract the salutation here. If no salutation is given, we replace it with hello. Then we take the name. If no name is given, we replace it with world. And at the end of the day, we use the salutation and the name to build the greeting. So this is how you can extract things from the query string. Let me show you how this is embedded here. We simply add our route. As you can see here, we go to the request and then we can say greet without any data, hello world. We can say greet with a question mark and a name, which says hi Rainer. If we use greet with the salutation, it says hi world in this case. And if we specify both, we get hi Rainer. And that is exactly what we want it to do. So you see, these extractors are really, really useful. Now we have parameters from the path. We have parameters from the query. The last thing that every API that I've ever written needs is an extractor that extracts something from the HTTP body. Now there are more extractors in real-world apps, but this is the basic thing that you need. So let me add the third example for extractors, and that will be this one here. This is an extractor which can extract JSON payload from the HTTP body. You simply say, hey, take JSON extractor and extract this time the query parameters, exactly the same thing that you saw up here, but this time you don't extract it from the query string, but you extract it from the JSON body. The implementation is exactly the same. I could have built a function to not repeat myself, but that's not the point. I think this is something that you can imagine that it's possible. The real only difference conceptually between this line and this line are the extractors. Here, query string, here, JSON body. Obviously, we now need a post request because we want to receive an HTTP body, and that is not possible with a GET request. We need the post request. Let's do exactly that. So we simply change our query handler. Here it is. We replace it with a GET handler for the old query and the post handler for the new body. And if we try that one, here I have the post request, you see, great. And this time I specify the data in the HTTP body. So we can simply call it, and as you can see, it works. Before we move on, I would like to keep maybe these functions here on the screen, and particularly, maybe this one, particularly ask those of you who are rather new to Rust to take a look at the code. Many people avoid Rust because they have heard that Rust is complicated and Rust is a system level language, and they don't like other system languages like C or so on. I mean, don't we all love C# and Java and JavaScript and go for their simplicity, for their productivity? But take a look at this code. I mean, are you bothered here with advanced Rust concepts like lifetimes or ownership and borrowing and things like that? They are all there. Believe me, they are the underpinnings of this code, but they are not visible to you. And that is what I really like when working with Rust. I do a lot of Rust trainings and many consulting projects in the Rust area. I have to do with a lot of customers who start with Rust or are in the middle of their journey towards Rust. And yeah, I know these advanced Rust concepts are hard to grasp. But as you can see here, a framework like Axum beautifully abstracts away all these complexities. Of course, as a Rust developer, you need to understand these concepts, but you do not need to understand them immediately before you can write any line of code of Rust. You can write applications in Rust without having, I don't know, lifetimes for breakfast, if you know what I mean. So this is a very important takeaway that I would like to take away, would like you to take away from this talk, especially if you are a Rust beginner. Okay, good. Do we have any questions in the room? I'll take a sip of water and let's see. Okay, I hope I could answer your question. Very good. So let's move on so that we really can finish everything in time. If you want to learn more, just take a look at my code. I've added some links here where you can read more about it. Now let's talk about the question how it's possible that we just return a string. There is another very important abstraction, and this abstraction in Rust is called into response. In fact, a handler function can return anything that is convertible into a response. Into response for the experienced Rust developers in the room is a trait. So this trait, for other developers, it's like an interface. This trait can be implemented for any type. And the Axum framework already implements into response for things like strings, but also for things like status code. So you can simply return a status code and that's fine. But it also implements into response for tuples. And that is really nice. Don't get me wrong, this example is not very meaningful, not very useful. It's called look it up. I pass in a number, as you can see it here, through the path. I extract the number from the path, and then I simply say if it's an odd number, we return OK, and if it's an even number, we return not found. And in both cases, I return a JSON response by this time using JSON not as an extractor, but as a responder. JSON is both. I can respond with JSON and I can extract JSON, as you can see it here. So this works really fine because both here tuples have the same structure, And both tuples can be returned as a response, as you can see it here. So let's add the lookup route up here. So you can see that it really works, that it's not a fluke. So, yep, looks good. Go here, and if we take a look up, if we say 8, it says not found. If we say 7, it says, oh, not found. What did I do wrong? Oops. I see it. I forgot the number here. I'm sorry. Let's try it again. 7. It's still compiling. Yes. See? 200 works. And if I say 8, it says not found. Perfect. Just as I wanted. Sorry for the small mistake here. Okay, so you see, into response is a very, very important thing when it comes to building responses in Rust. Of course, you can implement your own into response trait for, you can provide your own implementation for into response for your own types. For instance, your handler function could return a customer object. And if this customer object implements into response, so if it knows how to turn itself into an HTTP response, that's perfectly fine. So you can keep your handler functions really very expressive. So let's take a look at a more advanced sample. And this time we are here. Here we are. Exactly. This is a little bit more complicated. Why? Let me show that to you, especially for those who are not that familiar with Rust. You see, in the above sample, we have exactly the same structure of return type in every single branch of the match statement, which is similar to a switch statement from other programming language. You see, we have the status code as the first element of the tuple, and then we have some JSON of lookup result as the second element of the tuple. But if you take a look at the new function here, we have very different response types depending on the branch. In this case, it's just a random number. So the first one here, I return a string. The second one here, I simply return a status code. And the third one, I return some JSON. So you see, all these things can be converted into a response. A string can be a response, a status code can be a response, JSON can obviously be a response, but they are structurally very different. And for that, Axum provides a convenience function which is called into response, which allows you to convert different types in a single handler function to into response. And that makes the code very simple to read and very simple to write. In real world, you have this all the time. You query a database. If you find something, you want to return the object from the database. If you don't find something, you want to return a status code with some additional error information or something like this. So in real world, you see this all the time. And it's really beautiful how how Axum solves this problem by providing this helper function. The very advanced Rust developers here in the room might ask themselves, how is this implemented? How does the data model look like behind these things? And if you take a look at the implementation of Axum, you will see that this is not a trivial thing. So the data types are really advanced, and you have to be a real advanced Rust developer to understand the implementation. But as an application developer, if you just want to use it, that's perfectly fine. Okay, let's take the next step. In real-world applications, we need state. I know that HTTP is a stateless protocol, but in real-world applications, we need state. State can be some in-memory data. State can be some connection pool to a database where we read data from. State can be anything that we would like to manipulate. I mean, we are talking about RESTful web applications here. REST also already has the word state in it, representational state transfer protocol. So we need some kind of state. How is shared state implemented in Rust and Axum? Let's add the next snippet, is that one. First, we need to implement some structured data type. In this case, I'm just maintaining a list of numbers, but please use your imagination here. You could use any data type here. It could be, as I said, a connection to a database. It could be whatever you want as a state here. And to make things a little bit easier, I specify here a type alias, which is, and now for those of you who are new to Rust, don't run away, stay here, it's not that complicated. We need an arc of rwlock of an app state. So let's talk a bit about these. The pink one, the app state, is exactly what you see up here. See, app state. The rwlock is a reader writer lock. It enables us to acquire a write lock if we need to manipulate the data inside of the app state, and it allows us to acquire a read lock if we just want to read the data. That makes our application really scalable and thread safe because, yeah, we can have multiple read locks at the same time, but we can only have a single write lock because otherwise we would have a problem with a critical section. So this is what we need here. And the last thing is probably the thing which is the hardest to understand for newcomers in Rust. It's an atomic ref counter. I told you that Rust does not have a garbage collector. But if we have a multi-threaded application like a web server, we have multiple owners of a single piece of memory. So the traditional ownership and borrowing system, which you might know from other languages, maybe not, I don't know, it simply doesn't work. The usual way of memory management in Rust doesn't work in a multi-thread application like a web server. So what we essentially need is we need to count the number of references to that state so that Rust exactly knows when to free the memory. As I said, we don't have a garbage collector. So the arc is a thread-safe reference counter that is set to 1, 2, 3, depending on how many applications or threads are currently accessing the piece of memory. And when all the references are gone, the ref counter is dropped to 0 and the data is freed. It's kind of like a smart pointer in C++, kind of. So this is what the arc is all about. It's just like a recipe. If you want to have state, you typically have an arc. You always have an arc, essentially. If you have something like me here with reading and writing, you have an rwlock, and then you have the app state. So it's not super complicated, but it's a little bit more complicated. But I think that's fine. Now let's add the state, and that will be this one here. Now here, I have added handler functions and setting up the routing. First, let's take a look at the handler functions. Let me introduce to you a new extractor. We already had, can we remember? We had the JSON extractor, we had the path extractor, we had the query extractor, and now we have the state extractor. The state extractor extracts shared state so that every HTTP handler function can access the same state in memory. So in this case, I am just extracting exactly our app state, which you have seen before. The get method acquires a read lock asynchronously. Async await is available in Rust. I don't have time to go into details here, but yeah, you see it. And then we take the numbers, we copy them in memory and return a copy to the JSON responder so that it can turn these numbers into JSON and return it. The write implementation acquires a write lock, as you can see it here. It pushes a new number into the so-called vector. An array list is called a vector in Rust, or a list in C# is also an array list. This is just called a vector. So we're pushing something into a vector here. And then we simply again do the cloning and return it so that we return the current state back to the caller. And last but not least, we simply set up a route which says numbers. In the get case, call the get method. In the post case, call the post method. The question is, where does the state come from? Now, the state comes from exactly this line here. We have to copy these two lines here into our main method up here. Let's do it maybe here. And let's get rid of the comments here, and here. So as you can see here, that is the important line. We are creating a new instance of the state. It's a singleton. and we provide it to Axum. It's like dependency injection. We inject an instance of our shared app state into the whole routing process. And because we do that, our handler functions can then use the state extractor to get a hold of exactly that state. Let me show you and prove to you that this really works. I can call numbers. As you can see here, it's empty. Let's add a number, works fine. Let's add some additional numbers. As you can see here, it works like a charm, exactly as we expected it. So you see, state management is not complicated. Now we have 6 minutes left, and that is perfect because I have one last thing that I would like to talk to you about, and then we are going to close up with some Q&A. Okay, let's add the next snippet. Where do I have it? Oh yeah, I see it. It's the 130. Here it is. So let's read a poem from the disk. You see, I asked ChatGPT to write a poem about Rust. In the realm where code and craft entwine, Rust stands tall, fearless of time, and so on and so on. You can read this beautiful poem which ends with "How cool is that?" is the impressed outlast. So you see, a very nice poem. Let's read this poem from the disk, and this is what we want to do. Well, first we need a helper function which reads some lines of code from the disk. And that is very simple. I will not go into the details here because this is just Rust code. As you can see it here, read from file. It simply uses file open. It uses read to string. And at the end, it uses a crate which supports WAML, the WAML format, and turns it into a poem data structure, as you can see it here. Let me show you the poem again. You see it's WAML, it has a title, it has a text, and what we do here is we simply parse the WAML file after we read it from the disk. However, if we have I/O, we need some kind of error handling. Something can happen when we read from the disk. Something can happen when we parse from WAML, for instance. And here, you see this beautiful error propagation operator here. This error propagation operator says essentially, hey Rust, if something bad happens, return an error. Only if everything is okay, return the poem. The question is, where do we get this poem error from? And here in Rust, it's very, very common to use a crate which is called this error. Let me show you how this looks like. This is this kind of code that we need. And here you see how beautiful Rust is in comparison to other languages. In other languages, you would simply say throw or rethrow the exception, and the reader of the code has no idea what exception could happen. You need to read the documentation in order to find out what the error cases are. But in Rust, everything is written down clearly and exactly. You see, you can define your own error type, which contains your own business level error conditions, and they can be derived from lower level errors, like for instance I/O errors or WAML parsing errors. And all you need to do is you need to describe your error conditions. And if you ask yourself, and if you are new to Rust, what this hashtag is, it's a macro. Rust does heavily depend on macros. So all these nice macros, they solve the problem for you to understand that this question mark here is an I/O error, and it has to be turned into a poem error, file access error, and provide exactly the I/O error as an internal error. It's like an inner exception, if you want it like that. The important thing that I would like you to take away from this is really beautiful code. No exception catching and rethrowing and so on. Just use the question mark as the error propagation operator and define a nicely defined error type so that the users of this method know exactly what can go wrong. And then, as soon as we have this nice error type, we can implement into response for this error type. I will not go into the details because it's simple. We simply say if we have a file access error, we return an internal server error with some error message. If we have a WAML parse error, we return an internal server error with exactly that error message, and we return the error message as JSON. It's really simple. We just implement this into response for the POEM error. And with that, we can finally implement the error handling function, and that is the handler function, and that is the last snippet that I'm going to implement. Very simple. Here we simply call, as you can see here, the method, and also here take a look at this error propagation operator. That is beautiful. This will give our POEM error to Axum. Axum will recognize that the POEM error has an into response implementation and can turn this business level error into a beautiful HTTP response, which can fit exactly to the specification of our HTTP JSON API. So that really works perfectly fine. Let me just show it to you, prove it to you, and then we are through. Where did I have it? Yeah, I have it here. Let's merge this one. Let's put it at the end because we have all our nests and merges here. And if I go here to the request, I can call this and we get an HTML code with a beautiful poem. And if I, for instance, screw up here and if I rename this file and call it again, I get a very nice error message exactly as we have specified it. And if I do it correctly and make, for instance, a mistake here in the WAML file, and if I call it, I get again an error. If I fix it again, it works perfectly fine. So you see, error handling also is beautiful, very explicit. You can model, let me scroll down, you can model your errors and you can beautifully bridge the gap between the web framework, Axum, and your business errors, your business cases, your business objects by implement these basic abstractions like into response. That is what I wanted to show you. I want to say thank you for your attention. And for those of you who still have questions, I will be here. We can now start the Q&A. And remember, building web APIs with Rust and Axum is not complicated. Yes, Rust is a low-level, system-level language, but you can really build beautiful application-level code that is fast, that is safe, and that is very expressive and easy to use. Thank you very much for your attention, and with that, I would like to open the Q&A area.